Okay, guys, so this will be the first section that we're going to cover in this course. This will be chapter 2.5, Sets and Compound Inequalities. It's a little bit of a longer section. The video should probably take us about 30 minutes. We'll see how it goes. So the things we're going to talk about in this section is we're going to talk about finding the intersection of two sets, solving compound inequalities containing and, finding the union of two sets, and solving compound inequalities containing or. This will also help us in 2.6 and 2.7 as well. So let's get started. So compound inequalities are two inequalities joined by the words and or are called compound inequalities. So you have this set right here. X plus 3 is less than 8 and X is greater than 2. And here's another way it could be written, a different type of compound inequality with an or statement. So 2x over 3 greater than or equal to 5, or negative x plus 10 is less than 7. So both of these are compound inequalities. And one of the main things that we're looking for is not only are we trying to find solutions to these inequalities, but we also want to learn how to write them in set notation or in interval notation, and then also how to look at this graphically. What does it mean? So as we move forward, I'll give you guys a little bit of practice on this, and feel free to always ask me questions during our meeting times or office hours. So the solution set of a compound inequality formed with and is the intersection. So this is very important. It is the intersection of the solution sets of the two inequalities. So a lot of times I've also heard the term used overlap. That's another good way they talk about compound inequalities, and the and statement is what's the overlap between the two sets. So a lot of times you'll see the word and this is associated when you're talking about compound inequalities. This is associated with this symbol right here. That's the intersection. Oops, I wrote that pretty bad. So that's the intersection symbol. And then we're going to learn that the word or is associated with the union symbol. So this is intersection, and this is union. Okay, so if you ever see this symbol, you can assume that it means or, and if you ever see this symbol, you can assume it means and. Okay. So the intersection of two sets, A and B, is the set of all elements common to both sets. A intersect B is denoted by A intersection B. So you see this notation right here. So this little middle part right here is what they're talking about. This part right here in the middle, that is what A intersection B looks like. So that's the two sets that share the same values or that have an overlap to them. Okay, so that's what we're kind of finding, or not kind of, that's what we're finding in these situations, in these problems. But you know, sometimes drawings help, sometimes they don't. Sometimes just working with sets is a thing that we would like to do. So here's a situation. It says find the intersection of the set. And remember, you guys, this little line right here, that's set notation. Okay, so they're saying find the intersection of the set 1, 2, 3, 4, 5. And the other set, so remember, and even I said it, the word and 3, 4, 5, 6. So what you're asking somebody is, what is the intersection, or where do the two sets share a common value? So they don't share 1, they don't share 2, but they do share 3. So I'm going to put 3, comma. They also both share 4. They also both share 5. So my intersection is 3, 4, 5. Okay. Oops. Let me write this notation. I oftentimes use squiggly lines, but it's supposed to be supposed to look like very specifically like that, but I just use squiggly lines real fast to write set notation. So this is the set of 3, 4, 5. Okay. And that is where there is an intersection between this first set and between this second set. Okay. So solving compound inequalities containing and. A value is a solution of a compound inequality formed by the word and if it is a solution to both inequalities. So this is key. If you're using an and statement, the solutions that you find, if you're saying they are in fact answers, they must be solutions to both inequalities when there's an and involved. When there's an or involved, it's only to one of them, okay? Or it could be both as well, but in this case, it must be to both. So if we look at this, and I ask you to solve x plus 5 is less than 9, and 3x minus 1 is less than 2. What I'm asking you is I want you to find an x value that when I substitute this in, this will be a true statement and this will be a true statement. So they both must be true, okay? So I have to find an x value that will work for both of these, okay? So what you in general do is you take each inequality and you solve them like off to the side separately. So I'm going to take x plus 5 is less than 9, okay? And I'm going to subtract 5 from both sides. Oops. So I have x is less than 4, okay? And I have this one over here, 3x minus 1 is less than 2. So I'm going to add 1 to both sides. So I'm left with 3x is less than 3. Now I divide both sides by 3. And I am left with x is less than 1. Okay, so we have these two situations that x is less than 4 and x is less than 1. So the numbers we're looking for must be less than 4 and also less than 1. Okay, and we're only allowed to use numbers that answer both of these questions correctly. So what I normally do, and in general, this is what you should do, is you should draw your number line and put 1 here and put 4 here. These are how I'm going to cut up my number line. I oftentimes will call these like partition numbers, but these are just numbers that we're going to use to cut up the number line a little bit. And what we're going to do is we're going to shade for truth. Okay, so x less than 4. So in general, you guys, when you're dealing with less than, greater than, you use parentheses. And when you're using less than or equal to or greater than or equal to, use brackets. Okay, so since we're using strictly less thans or greater thans, we're going to use parentheses. So I'm going to say for this first one, x is less than 4. So that's right here. And it says to shade to the left, all values of x less than 4. So that would be here, right? Okay, now it's asking me to shade x values less than 1. It's saying we're going to take all the answers that are less than 1. So I'm going to put a parenthesis here at 1. I'm going to shade this way. Okay, so now the question becomes, where did I shade twice? Okay, where is there an overlap between these two sets? So I didn't shade it all over here, so that doesn't count, right? I didn't, oops, let me clean that up. I didn't shade it all over here, so we don't worry about this. Now here I did shade, but I only shaded once. And remember, because this is an and statement, it's where did I shade twice? Where's there overlap where both sets end up having the same answers or the same values? So if I look here, so for less than 1, all the values are, I'm sorry, I have green shading and I have red shading. So whenever x is less than 1, it seems to work for both. So let me write this as my answer. I'm going to say this is my solution. And remember, what's way over here on the left-hand side? So what's way over here? That's negative infinity, right? If you go all the way left, if you just keep going. So I'm going to say from negative infinity to positive 1, okay? So the thing is, this is called interval notation. So let me come over here a little bit. Sorry about that. So interval notation uses parentheses and brackets, okay? And you always start with the smallest value on the left. So this will be negative infinity to 1, okay? Now I'm going to answer this question using set builder. Okay, so set builder, it basically does this. So you say x such that. So this is how you write it. So that symbol, that up and down line means such that. And then you write what this is right here. Okay, so you write this exact statement that you have here after you simplify it. So x less than, oh, okay, but actually, since we found the true solution, the true intersection, I'm just going to say x is less than 1. So this is actually the one I use, this one right here. So I'm going to say x is less than 1. So that's the solution if I was asked in set builder. That's the solution if I was asked in interval notation. And those would both be correct answers, but it really depends on how you were asked, okay? How you were asked for each of those problems, okay? So now let me give you guys one. So you guys take a minute, pause the video, and give this one a shot without me walking you through it. Try to draw the graph, try to do everything like we just did, and find the solution to this compound inequality. Okay, so hopefully you guys unpause the video. So the first thing I do is I come over here and I write 4x is greater than 0, and I write 2x plus 4 is less than or equal to 2. And I'm going to divide both sides by 4 here. Here, I'm going to subtract 4. I'm just kind of doing it quickly because you guys already had a chance to work on it. And then this is 2x is less than or equal to negative 2. Okay. So what I do now is I divide. So this side's done, right? We're pretty much done here, but this side I have to divide by 2. So this would be x is greater than or equal to 0, and then this one would be x is less than or equal to negative 1. So technically, right, these are my answers, but that's not how you're allowed to write the final answer because we have to find the intersection of these two. So maybe I'll write it down here actually. So then what I'm going to do is I'm going to draw my number line, and I'm going to put negative 1 and I'm going to put 0. Okay. And now I'm just going to do what the shading tells me to do. So for this one, it tells me greater than or equal to 0. So that means I use bracket because it's the or equal to, and I shade to the right. Okay. So any of these numbers, 1, 2, we have 1, 2, 3, anything over here will always be greater than or equal to 0, right? So now we have to shade the other one. X is less than or equal to negative 1. Okay, so here's negative 1, so we do bracket here, but now we shade the other way because this tells us to shade to the left right here. So we shade left, okay? So now remember, this is an and statement. So let's go back up here. This is the word and means where do your two solution sets overlap? Where is, in terms of graphically, where is there double shading? Where does our shading overlap with other shading? Well, the answer is nowhere, right? We shaded once over here, we shaded no times here, and we shaded once over here. But at no point did we shade twice in the same location. So that means there is no solution. And in general, when you're working with this, you say the empty set. So the solution set is, sometimes you can write a 0 with a line through it. Also, you can write this, the set with nothing in it. And that's about all we have to do for that. So either of those would be the correct answer. So please use empty set, or since this has no solution, we'll say the solution is the empty set, meaning the set with nothing in it, not even 0, right? 0 is not even in this set because 0 would actually be an answer. This is saying the set of emptiness. There's nothing in there. Okay. There's no way to answer this question. Okay. You can't find any number that is bigger than 0 or equal to 0 and at the same time less than negative 1, right? Because that's what it's asking. It's saying find a number that's bigger than 0 or equal to 0, but at the same time is also smaller than negative 1 or equal to negative 1. That doesn't exist in the real number plane. So we move on. Okay. So here's another type of inequality. This is also an and statement, but it's written without the and. So if you wanted to write this with the and, this would be 1 minus x is greater than 5 and 1 minus x is less than 9. Okay, so that's what it actually is saying. So what they do is they just kind of combine it, okay, and they create this compound inequality without the word and. Okay, so this is how I normally think of it. What I normally do is, you know how you were taught when you were young, whatever you do to one side, you do to the other side of the equation to preserve the balance. Okay, well, in this particular problem, it's like there's 3 sides. There's the left, the middle, and the right. So what I do is whatever I do to the middle, I do to the other 2 sides, the left side and the right side. So my goal is to get the x by itself. Okay, so I want to have x all alone. So isolate x. Okay, so what I'm going to do is I am going to subtract 1, subtract 1, subtract 1. Notice how I did it to the middle, to the left, and to the right. So let's do a rewrite now. So this will now be 4 is less than negative x is less than 8. Okay, now the thing is to get x all by itself in the middle, you have to divide by -1, right? Because that would make it no longer negative x, that would make it positive x. But there's a catch. Whenever multiplying or dividing by a negative across the inequality, change the direction of the inequality, okay? So what that means is, notice here, I am dividing right here by -1, and I'm doing it over here. So I'm going across this inequality, okay? So to me, that's how I think of it, as a cross. But what it really is saying is, whenever both sides of an inequality are being divided by a negative number, you change the direction. So notice how it used to be a less than symbol. Now it's going to be -4 is greater than x is greater than -8. So this kind of doesn't make sense, right? -4 less than, or greater than x. So what we're going to do is, in general, whenever you're writing these, you always put the smaller number on the left and the bigger number on the right. So I'm going to write -8, x, and -4. But you see how the mouth of the inequality is on the -4? That means when I rewrite it, it has to stay the same. You see how the mouth of the inequality, when you're talking about the 8 and the x, is on the x, and the smaller part is on the 8. We got to continue that. So the smaller part has to be on the 8. So now this is in the correct fashion, okay? But this makes it really easy to graph. When I go to graph, I put -8 here, and I put -4 here. And remember, this is an intersection. So it's already telling you that x is between -8 and it's between -4. So they're telling you this is the solution, okay? Now, if you wanted and you didn't like how I did this, you could have taken this and said x is greater than, you could have taken this and done a little side work here, and you could have said x is greater than -8 and x is less than -4. And then you could do the shading, right? You could say, let me show you what you could have done instead. You could have said, okay, let's do the -8 first. We go to the right from -8, we shade this way. And now let's do from less than -4, right? We shade this way. So where did I shade twice? I shaded twice right here in the middle, right? But that's what this told me in the first place. So that's the kind of the good thing about this compound inequality in this form, is it already is telling you the two bookends, where to shade. So it's kind of nice, it's kind of convenient, okay? So in this case, my solution set is, now if I want to do set builder, I say x such that -8 is less than x is less than -4. Okay, so this would be, once again, set builder. Now, if we want to do interval, I can do this. I can just say -8 to -4. And this is interval notation. Okay, now again, both of these answers are correct, but most people prefer interval notation. Look how much faster it is. However, set builder is nice too, because you see this answer right here. I just take this and I just put it right there, right? So they both have their advantages. In general, I prefer interval notation so I will teach you both and hold you accountable for both, but in practice, I do interval almost all the time, okay? So that's kind of the way intersection works. Now let's look at the other way. Let's look at the union of sets. So remember, I told you the union, or the or statement, is the, it's not an actual U, it's the symbol right here, okay? And you see it again right here. And the union of two sets, so it says union of two sets, the intersection of two sets A and B is the set of all elements that belong to either of the sets. Okay, so I think this is a typo. The intersection of two, so we're not doing intersection. We're doing the union of two sets. A and B is the set of all elements that belong to either of the sets. A union B is, yeah, so that was a typo. So yeah, cross that out. Make sure you cross that out in your notes. It's definitely supposed to say the union of two sets. So here's the thing. You see how before we said, oh, this middle part is what we're concerned with? Well, we don't care about that anymore. The union of two sets is everything here and or everything here. We'll take either one. We don't care. Sure, we'll take the middle stuff. We'll take the stuff in A. We'll take the stuff in B, and we'll also take the elements in the middle of A and B. We'll take everything. So that's what the union is. So I've always thought of intersection as being very picky. It's very strict on who's allowed to be part of the intersection. But the union seems like it's nice. Like it'll take anybody. Like, oh yeah, come on, we'll take all of you. We'll take all of you from A, or we'll take all of you from B. We don't care. As long as you're from one of those sets, we're fine. Okay. So for examples here, it says find the intersection of 1, 2, 3, 4, 5 union. Okay, it did it again. So I think the book just might have this is from the book. So the book just might have a little bit of a typo with the word intersection. So find the union of these two sets. See this symbol here? Once again, this means union. Okay. So what I'm going to do is I'm just going to say, what is the number one? So let's call this set A and let's call this set B, okay? So if I want to find A union B, what I'm saying is tell me the numbers that are in set A or in set B. So let's start with the number one. Is the number one in set A or set B? If the answer is yes, you put it as part of your union. Is the number two in set A or in set B? Yes, so you put it as part of your union. The number 3, yes. The number 4, yes. The number 5, yes. Now, is the number 6 in set A or in set B? If the answer is yes, you still put it. So notice that we put 6 right here as part of our union, even though it wasn't in set A, because it's not an intersection, it is a union, okay? So unions only need the values to be in one of the sets, not in both. So unions do not require double shading, they only require single shading. They'll also take double shading though. They don't care if it's double shaded, that still counts, but they only require single shading or only to be in one of the sets, okay? So solving compound inequalities containing or, a value x is a solution to of a compound inequality formed by the word or if it is a solution to either inequality. So it doesn't have to be an A or it doesn't have to be an A and B. It only has to be in one of them. You don't care which. Okay. So it says solve 3x minus 2 is greater than or equal to 10, or x is less than, or x minus 6 is less than or equal to negative 4. So what I'm going to do is I'm going to solve each one separately. So plus 2, plus 2, plus 6, plus 6. So let's rewrite. 3x is greater than or equal to 12, or x is less than or equal to 2. Okay. Now this side we have to divide by 3, divide by 3. So we now have x is greater than or equal to 4, or x is less than or equal to 2. Once again, I'm going to draw my number line and take these two numbers, 2 and 4. Okay. And then we're going to shade how we're told. Okay. So this one says to shade to the right of 4, but it's a greater than or equal to, so we're going to use a bracket and we're going to shade this way. Okay. Now it says x is less than or equal to 2. So we're going to use this, a bracket once again, but it says shade this way this time. Okay. Now notice there's no intersection, but they were not asking for an intersection. This is an or statement. This is a union. So our solution is anywhere that we shaded once. So our solution would be, if we write as an interval, negative infinity to 2, and then we put a bracket on 2. Okay. Now you notice right here, let me see. Notice right here, there's nothing, right? There's no shading, so we don't count that. And we had to like jump over to this one. So what I normally do is I think of this as a union. I'm going to join these two sets. I want to say both of them are correct. So what I'm going to do is I'm going to put a union here, and then I'm going to start at 4 again, and then I'm going to go to positive infinity. Okay. So that means if I pick a number from here or here, remember this is the word or. If I pick a number from here or here, it will be true in the original compound inequality. So let's pick a number. Let's say, what's a good number from here? Let's pick, I don't know, 0. 0 is normally, and 0 is between negative infinity and 2. So I'm going to take 0 and I'm going to plug it into the original. Okay. So I have 3 times 0 minus 2 is greater than or equal to 10. So this is -2 is greater than or equal to 10. Is that a true statement? No, that's false. Okay, no problem. So then I'm going to use it in this guy now. Remember, it only has to be true in one. It does not have to be true in both. So now I'm going to say 0 minus 6 is less than or equal to -4. -6 is less than -4. Is -6 less than -4? Yes, it is. So this is a valid solution. So once again, this works. Okay. That's how you can test intervals, is if you say that's the solution, you should be able to pick any number in that interval and then plug it back into the original and it should work. Okay. And if it doesn't work, then you messed up. Okay. And then we could pick what's a good number from over here, 10. So I could do the same thing. I could say 3 times 10 minus 2 is greater than or equal to 10. So this is 30 minus 2 would be 28. Is 28 greater than 10? Is this a true statement? Check. So I don't even have to check this one over here because I already got it to work for 1. And remember, an OR statement only needs it to work for 1. So this is good. So both of my solutions work. Okay. If you want to do interval notation, if you want to do set builder, you would say X such that, and then you would say X is less than or equal to 2, or X is greater than or equal to 4. And that's how you would write it in set builder. Once again, this is set and this is interval. And this is set builder notation. Okay, so either one of those is correct, but make sure when you're doing the homework, you're answering it the way they ask for in the homework, okay? All right, let's try. Let me see. How many more do we have? Oh, that's it for this one. Okay, so let's try this one. So I'm going to pause the video, or I'm going to ask you guys to pause the video and you guys try this OR statement without my help. Okay, so hopefully you can get it to work. Okay, so hopefully you're unpausing the video and you feel pretty good about your answer. So let's give it a shot here. Okay, so first things first, we solve each inequality separately. So this is going to be +7. This is going to be +7 to isolate the x. This is going to be +6. This is going to be +6. So this would be x is less than or equal to 6, or 2x is greater than or equal to 8. So far, so good. So this one's already done, right? We already have the x isolated. So I just got to clean up this side real quick. So this would be x is greater than or equal to 4. So once again, I just draw my number line. I put 4 and I put 6 there. And again, you guys notice hopefully that I don't spend a lot of time like counting down little hash marks, because it's all about, you know, relative location. Where is it to the left? Is it to the right? Is it in between? So now we're going to follow the instructions. The instructions say shade to the left of 6 using a bracket. So I'm going to shade this way all the way to -infinity. Then the other one says shade to the right of 4 using a bracket. Okay, so now here's the mistake people make. So then this is what people say the answer is. They're like, oh, look right here, I shaded twice. So my answer should be 4 to 6. Okay, and this would be your solution. Oops. So this is what you think your solution set is. And then I have to come and I mark that wrong, okay? Because that is not the solution set. You're saying the only numbers that work are between 4 and 6. So 4.2, 5.1, 5.8, 5.7. So all of those will work. But what about a number over here? You're saying they don't work in this OR statement. So what's a number to the left of 4? How about 0? So if I put 0 right here, I get 0 minus 7 is less than or equal to -1. So this becomes -7 is less than or equal to -1. Isn't -7 less than or equal to 1? So this actually checks out. That's a true statement. We know this one works, okay? And then if we check this one will work for this guy over here, okay? So here's the thing. Everywhere that I pick, the numbers work. So as it turns out, the solution is not 4 to 6. The solution is -infinity to +infinity. And this is saying all real numbers, okay? This, you could also write this, you could write x such that, you know, x is an element of the reals. I don't think they get that fancy in the homework. They might just say all reals, but this is the, once again, this is the interval notation answer for it. And then this would be the set builder notation, but I don't know if they get as fancy as that, okay? They might just say the solution is all real numbers. So just because it's an or statement doesn't mean it has to be split like this. It's nice when it does, but it doesn't have to be. And just because, notice here, let's go back to this one. Where did I find it? Just because this one is split, this looks like an or statement, but they were asking me for an and. So you have to be careful on what the wording is. In this case, this is the empty set, right? Because there was no overlap. But if I changed it to or, then we would have said, well, this is the solution or that is the solution. But because it was an and statement, the empty set was the way we did it. Okay, so that's going to do it for 2.5. Please let me know if you get stuck on the homework or if you have any questions about the video, and I can give you some more examples in class if you need help. All right, you guys, thanks for watching.